another problem related to total differential. So we're given the function f of x and y equal to 2x minus 7y. And part A is going to ask us to do some computations. So f of the point 6, 9. So we're going to just start by doing these calculations. So f of 6, 9 is 2 times 6 minus 7 times 9. That's 12 minus 63, or negative 51. Then it asks us to find f of 6.1 and 9.05. So we changed x just a little bit, and we changed y just a little bit. And we're going to use that to calculate the change in z. So f of 6.1 and 9.05 is 2 times 6.1 minus 7 times 9.05. And that should give us 12.2 minus 63.35. So that's minus 51.15. Minus 51.15. So the change in z is going to be delta z, and that should just be f of 6.1 and 9.05 minus f of 6, 9, which is minus 51.15 minus 51, and that's minus 0.15. So delta z, just the difference between these two, which is minus 0.15. Then in part B, the problem asks us to use the total differential dz to approximate delta z. So let's first find the total differential. Remember, our function is 2x minus 7y. So dz is going to be del f del x, or we can say del z del x, times dx plus del z del y times dy. So del z del x in this case is 2. 2 times the change in x. Del z del y is 7, so minus 7 times the change in y. And then we can compute that the change in x is 6.1 minus 6, of course, 0.1. The change in y is 9.05 minus 9, or 0.05, and plug that in. Then dz is 2 times 0.1 minus 7 times 0.05, which is 0.2 minus 0.35, which is minus 0.15. So for part B, the total differential approximation of delta z is minus 0.15, and you can see that they agree. So that's very nice. Let's look at one more example of this type. Here we have that f of x and y is equal to y e to the x. So first we're asked to find f of 2 and 1. F of 2 comma 1 is 1 times e squared. So e squared. Then f of 2.8 and 1.55 is equal to 1.55 e to the 2.8. So let's use the calculator really quick to get an estimate for that. Need our scientific calculator. So e to the, so let's do 2.8, e to that, and then times 1.55. So around 25.4892. And while we're at it, let's go ahead and get an estimate for the other one as well. E squared should be about 7.3891. So then delta z is 1.55 e to the 2.8 minus e squared. And that should be right around the difference between those two numbers. What was my other number here? 7.3891. So around 18. Okay. The second part of the problem asks us to use the total differential dz to approximate delta z. So dz is going to be del z del x times dx plus del z del y times dy. So looking at our function, the partial derivative with respect to x, remember y is just a constant, so that should be y times e to the x times dx. And then the partial derivative with respect to y, now e to the x is a constant. So the derivative with respect to y being 1, that just gives us e to the x times dy. The change in x is 2.8 minus 2, so of course 0.8. The change in y, 1.55 minus 1, 0.55. That means that our total differential should be e squared times 0.8. So y e to the x, I'm plugging in 1 for y and 2 for x, then multiplying it by the change in x, and then plugging in 2 for x, and multiplying it by the change in y, So that should be e squared times 1.35, whatever that is. We'll again use our calculator to get an approximation. And it's 9.9752, something in there. And that completes the problem.